All right, ladies and gentlemen, hello and welcome. It is 4 o'clock Eastern Time on a Monday, which means it's time for a deep dive. Yes, indeed. Those of you who arrived a bit early, you heard our radio show. We were just talking to a couple of companies, a couple of innovators in this space, quite frankly. We had Mark Budzinski of WhereScape, we had John Bach of Snowflake, and we had Olivier Meyer from Zoom Data. And now we've got the deep dive. So we talked at a high level on the radio show. Now we're going to show you how this stuff really works. And I'm absolutely psyched to have two great experienced veteran software experts here on the line. We've got Todd Boschin calling in and Jason Laws from Snowflake and WhereScape respectively. They've got a big announcement today. They're announcing at TWI a partnership, and this is great stuff, folks. We're talking about taking the power of automation delivered by WhereScape, plugging it into the Snowflake cloud environment. For those who don't know, WhereScape, first of all, is a pioneer in data warehouse automation. Snowflake is a pioneer in cloud-based data warehousing. You put the two of those together, it's better than Reese's Peanut Butter Cups, I got to tell you. And so with that, I'm going to hand it off to Jason Laws of WhereScape. Let us know what's going on.
Hi, thanks for joining us today, everyone. We're going to do a deep dive using WhereScape on automation software on Snowflake. So with all the benefits of cloud data warehousing with Snowflake, and Snowflake's a superior platform specifically designed for data warehousing in the cloud, designing, developing, deploying, and operating a data warehouse still remains a time-intensive task. Leveraging automation can be a game changer, especially with an elastic computing-based cloud database like Snowflake. So with WhereScape, we're able to fast-track delivery, limit project risk, lower initiative costs, boost team productivity, and support DevOps and agile continuous integration and delivery, all using one product suite. We automate development and operations workflow using native Snowflake functionality and best practices within our WhereScape product suite. And all the time we're able to offer data warehouse modeling methodologies such as third normal form modeling, dimensional modeling, and Data Vault 2.0 as well, and also use. We have three products we're able to offer: WhereScape 3D for Snowflake, WhereScape Red for Snowflake, and also WhereScape Data Vault Express in a Snowflake environment. Today we're going to have a look at WhereScape Red for Snowflake. I've got one customer quote here. So Aptus Health, who were discussed, I think, in the previous hour, have started using WhereScape on Snowflake to build a data vault, and they've got a great quote on the screen at the moment. Just to recap, we're going to get using WhereScape's product suite, we significantly speed up delivering a data warehouse on Snowflake by as much as 80%. We easily increase developer productivity by at least 5 times, and we ease ongoing operations with continuous integration and delivery capabilities. I'm going to jump in now and do the demo. So we're going to start off inside of WhereScape Red.
I love it. Live demos, baby. Here we go.
Live demos. There's so much that could go wrong here. I'm sitting in a hotel room doing this live. Forgive me if
we respect the risk.
Thanks. Okay, so this picture is an overview diagram that shows everything we do in WhereScape Red. So WhereScape Red is a product specifically designed for automating the development and building of a data warehouse, as well as operational tasks. The blue box on the left-hand side represents all the different source systems we can get data from. So we can be given data, or we can go and get data from any of these sources, in fact, any source at all, even many that aren't on the list here. We land the data straight away in the Snowflake database, and then we use staging inside of Snowflake to transform the data and populate your data store, data lake, data vault, 3NF model, star schema, whatever you want to do. On top of that, inside of Snowflake, we can build views, performance objects, summary tables, and so on, as well as exporting data for downstream systems. Everything's done inside the database. We're collecting metadata the whole time. Our approach is a drag and drop interface where we collect metadata. Native.
There you are. Did you cut off for a second, but you're back. Go ahead.
Right.
Go ahead.
Great. Thanks. we generate Snowflake native objects from that metadata. We create tables, we generate code to update tables in the database, and we also land and load the data directly in the Snowflake database. So it's all metadata driven, and from that metadata we're able to generate impact analysis, a number of other reports and diagrams from the metadata, and also automate documentation generation for the data warehouse, both for end users and for technical audiences and IT as well. So what I'm going to do today is I'm going to start by building a couple of these load tables. I'm going to get some data in from a SQL Server database on-premise. I'm going to land some data and load it from a Windows environment as well. And then finally, I'm going to take some data already in the cloud in S3 and load it into Snowflake. Once I have that done, I'm going to merge a couple of those tables together and build one or two staging tables, a dimension, and a fact for a star schema. So the approach that I'm going to show you today is for a star schema, but it could easily be for a data store, a data lake, a data vault, 3NF model, anything at all. It's exactly the same approach. So we're going to build a really simple star schema with one dimension, one fact table, and we're going to be finished within 10 minutes, including impact analysis. So on the right-hand side over here, I'm showing the existing objects I've got in my Snowflake environment. So you can see I've got a couple of tables and views there already, but what I want to do is actually go and get a table from SQL Server and bring it into my Snowflake data warehouse. So I'm going to go and browse my SQL Server environment, and I'm going to grab one of the tables sitting over there, and I'm going to bring that into Snowflake. And all I have to do is pick it up from SQL Server and drop it over here. I'm going to choose the default name we've been given, and I'm going to leave everything else exactly the same. I'm just going to click OK. I could put a comment in here saying this is my table, and this comment would appear in our glossary for users later on. Now what we're doing is we're copying the metadata, the data dictionary metadata from SQL Server into our repository, converting everything into Snowflake data types and structures, and providing us a starting point set of metadata for our new Snowflake table. In this case, we're just going to load all the data for all the columns, but of course we could limit the columns, remove some, add some more calculated columns if we wanted to, and we could also apply some limits so that we did incremental loads rather than full loads. And what we're doing now is we're actually creating this new table in Snowflake. We're extracting the data out of SQL Server, sending it up into the cloud, and loading it into Snowflake. While that's running, if we pop over and have a look in Snowflake, this is the Snowflake web interface. You'll see if we do a refresh here, we should have a new table appear called Load Product at the top of the list. And there we go. So we created that a few seconds ago, and that's loading right now. If we go back into WhereScape Red, we can see the table loaded. We should have a create table statement here, and it loaded the data into that table for us. So we're taking data with a simple drag and drop operation from SQL Server straight up into Snowflake. The second one of these I'm going to build, it's a very similar process. I'm going to browse my Windows hard drive and grab another source for a new table. In this case, it's going to be a file, and I'm going to drag and drop it in. Now, this process is really similar to what we just did, except being a file source, we don't actually have a data dictionary to copy the table structure from. If it was XML, we would have, but in this case, with a delimited file, we don't. So we're just going to quickly parse the file. Again, I could add comments to the columns if I wanted to. Add all the columns. I'm going to accept all the defaults, and I'm going to create and load the table. It's the same process. And again, while that's running, we should now see that table sitting in Snowflake.
Wow.
And going back to our Snowflake web console, we've now got a second table sitting here. It hasn't quite loaded yet. We haven't got a row count yet, but if we go back to WhereScape, it should be done. And that was a really small file. We just put 8 rows into the cloud and loaded it. We could go in WhereScape and have a look at the data, and we'd see the data from our file now sitting in Snowflake. So there's the data for that small table sitting in Snowflake. The last one of these load tables I'm going to build, this will be really fast. I'm going to browse Amazon S3 to look for a file. And this looks just like our Windows file load, except in this case, because the data is already in the cloud and not sitting in my hotel room, it's going to load really fast. So this table is actually sitting already in S3. I'm going to parse it like I did to create a new table with the other file. We're going to accept everything as it is and go and do a create and load. And this file has almost 3 million rows in it, and it's going to load in a similar time, if not faster. So any second now we should see this table created, and we should see our 3 million rows. And if we look in Snowflake, again, we should see that new table sitting there, and it's got 3 million rows. So that was, again, we just automated building a new table in Snowflake straight from a file sitting in Amazon S3. So just quickly to recap in our overview diagram, we took 3 different types of data here and we landed them directly in Snowflake. Now what we're going to do is build a couple of staging tables to do transformations and to build out our star schema, our dimension, and our fact table. So I'm going to now change my view on the right-hand side to see inside my Snowflake environment, and I'm going to refresh that to show the 3 new objects we just created, the 3 new load objects, and you'll see we're using multiple different schemas inside of Snowflake here. I'm going to grab my load product table and drag it in to create a new table called stage product 2. And then I'm going to go and grab 2 columns from load product category and add those in as well. I'm going to put the category name in and the category description. So if you have a look at this column here in the middle, you'll see I've actually got 2 different sources of data now being joined together to create this new table. We've also added a couple of auditing columns when the rows in the table were created and when they were last updated. On our category description column, I'm going to go and add a really simple Snowflake transformation. So using one of the inbuilt Snowflake functions, I'm going to say, well, if this particular column is empty, the category description, put the category name there for me instead. And it's all done by drag and drop. So there's a simple SQL transformation built for us by drag and drop and demonstrating the inbuilt Snowflake functions that we have available in WhereScape Red. I'm going to click OK. I'm going to quickly create this new table in Snowflake. And I'm going to generate some code to update this table. So in this case, we're going to generate a new script to build this table. And we're going to use our staging table template code generation. We also have to go over here and say what our 2 source tables, for our 2 source tables, how they relate to each other. So product and product category, we join those together on category ID, and we're all done. We could go and edit this code if we wanted to. It's a starting point, but in this case, we've used the wizard to generate it for us. It's generating the code, and we can now go and run it. So this is now running statements inside the Snowflake database to join our 2 tables together. And there we go, we've got 649 rows joined together with those 2 new values in here. And we could go and look at the code for this, but we might save that step to the next table. So I'm going to quickly now just take this new stage table, which is a temporary table that I've built, and build a permanent dimension object for it. So I'm going to build a type 2 slowly changing dimension automatically from the stage table. I'm going to choose slowly changing here. And again, this time I don't need to do any transformation work, so I'm going to build this code automatically to update this table. We're going to add some extra columns to the table as well. We're going to add a surrogate key column, and we're going to add a start and end date, a current flag, and a version number as well. And all the code generation is going to be done for us, even though this is a reasonably complex, slowly changing dimension. I'm going to choose my history table template to build out the code here. I'm going to say what column makes the data unique, what the natural key is, that's product ID. And then I'm going to go and say which columns I want to be slowly changing. So if we get a change on this particular combination of columns, we're going to put a new row in the table with a new start date. And if any of the other values here change, we're just going to overwrite the existing values. We can control how our start and end dates work, and so on. There's a lot of other options in there available as well. So right now it's creating our dimension, a slowly changing dimension. It's creating the script to update it, and it's running it for us all in one go. And that should be finished in a couple of seconds. 650 rows merged in this case. And if we go and have a look at the script we've generated, you'll see we're generating native Snowflake SQL in the form of a merge statement here to process this table, and it's non-trivial. We've actually generated some pretty hard code that you would take hours, if not a day, to write by hand and get right and test, and out of the box it's just worked for us straight away. There we go, there's the generated code. And you're actually able to go and edit this code and change it if you want to as well. So the last thing I'm going to build is I'm actually going to put this dimension together with 3 role-playing date dimensions I've already got in a new staging table that'll be the source of our fact data. So I'm going to be merging everything that we've done today into one new object. And once we've done this, we'll look at some of the impact analysis functionality we have. So I'm going to grab this order header table and create a new table called stage order detail. And then I'm going to go and grab all the columns from order line and add those as well. So we've now got two different sources for our data. Now I'm going to just drag this column up to the top because I can. And then I'm going to say I want to look up dimension keys, surrogate keys for these 4 different dimensions. That's all I have to do. I've defined my new stage table. This is a source for my fact. I go and build it in the database. It creates it for me in Snowflake. I can go and build the code to update this table. I'm going to run it using my stage template. I need to say how my 2 primary tables join to each other. That's order header and order line. And again, we're not actually writing any code ourselves to do any of this. It's all just drag and drop. And I just go and check to make sure my dimension lookups are being done the right way. In this case, because we've consistently named columns, it's actually had a guess at how our dimensions get looked up, and it's got it all correct. We've now generated the code, and we go and run it. And it's now going to build about 3 million rows of data for us, looking up 4 different dimensions and joining together a couple of sources for this data as well. It should be finished in a second or 2. While it's running, there you go, 2.9 million rows loaded, and we've got all these surrogate keys and everything filled in from our dimension as well. The final step here would be to go and drag and drop that stage table in to build a fact, and we don't have to build the code or do any of that stuff today, but just to show you a couple of our diagrams, we'll just create this object, we'll drag and drop it in here and click OK and do nothing else. We're not going to build that in the database. What we can do is ask where that particular table has come from. So we can do a track back diagram, and it'll show us straight away at a table level how that fact table's been built from those 2 different source tables originally. We could also change the diagram type to be a joins diagram. And in this case, it would also show us how the dimension tables join in, and we could go and look at that at a column level if we wanted to as well. So automatically, we've been able to construct a trackback that shows us exactly where that particular table has come from. Finally, the other diagram we were going to look at here is it gives us a design diagram for our star schema. Now I can go and take this one step further now and actually generate documentation for our fact table. And if I do that, we get an HTML-based documentation just for our fact table that we've built that shows us, and let's just put this in the right place, shows us exactly where this table's come from. If we'd filled in any descriptions, they'd appear here as well. Shows us the table structure, how it relates to other dimensions. We get a star schema diagram and a trackback diagram and a number of other technical features for this table, all built into our documentation page for that table. But I want to take this a bit further and actually generate the documentation for the entire warehouse. So I'm going to go and run that. It's going to take about 10 seconds to run, maybe 20. But I'm going to run that documentation page that we just did for every object already sitting in this repository. And there's about another 100 tables here that we can't see sitting under the All Objects project as well. While that's running, let's just go and have one final look in the Snowflake interface. And you'll see we've actually managed to load quite a few tables here today. So we started off with nothing. We've loaded those 3 different load tables. We also built 2 staging tables. A couple of our tables have several million rows of data in them, and we've also built a dimension table here that's sitting in our warehouse. We go back into WhereScape Red now. Our documentation is completed, and we can go and have a look at that. So the documentation is broken into 2 sections, user and technical. The user documentation is just a subset of what's in the technical documentation. We can go and find any of the tables we have. For example, stage tables. There are a number of different stage tables in this repository. There's one of the ones we built today. And we can go and see the table structure, trackback information, and so on. It even gives us some code information here. We're able to go and look at the code as well. So any bits of code, we can go and open up the code and have a look at it too, and it all appears in the documentation for us. We can also go down and look at our glossary. So the glossary contains all the descriptions on tables and columns that we have in the warehouse. Anything at all that you've entered into the repository while you've been going through Wizards building objects, appears in the glossary. So if you follow some good best practice approaches and fill in the glossary, the column information and table information, you end up with a very rich user glossary as part of the technical and user documentation at the end of the process. So that's actually the end of the demo for today. We've got a number of other features, obviously going back to the overview diagram that we showed early on in the process. We can build out data vaults and 3NF models and data stores and data lakes as well. We just focused on star schemas today, but the process is very similar with all those different modeling approaches.
Yeah, and I have to say, that was amazingly fast. I mean, you mentioned that because that one data set is in the cloud, that enables the really rapid fire loading, but 2.5 seconds for X million rows or something, that kind of shows you the power of this technology and this combination being able to stitch together that level of complexity for a data warehouse in the cloud in less than 10 minutes in a live demo. I mean, that, compare that to the way things were done previously on premises. It would take you days or weeks, right?
That's right.
Yeah, that really kind of speaks to the agility too, right? And I think one of the Achilles heel really of data warehousing over the years has been how calcified it is. It's not easy to change. It takes a lot of time. It becomes a political issue. But now if you can load data sets that quickly, and you're doing some pretty complex stuff in there with joins on different keys and so forth, now the business user can get back to you with lots of very specific things, and you can just bang those out in almost no time, right?
That's right, yeah. And so, in fact, with the power of our impact analysis, it's very easy to identify where changes need to be made in the warehouse as well. And the process to go and make a change to a table is even simpler than what we've looked at today. We literally just go and add a column, delete a column, change a column source, and click rebuild code, and it goes and does the whole thing for us, potentially without even having to go through any wizard screens if none of the source table information's dramatically changed. So yeah, this is building the initial warehouse, but maintaining it is even faster, and that's a really important part of operating any warehouse. Is it's maintaining it over time and not being stuck with what you built at the start is the thing you've got forever.
Yeah, we just talked on a radio show before this webcast about this concept of the data share house. I'm just laughing at what a brilliant name that is, because we talked about how from the get-go the architecture of Snowflake was designed such that storage and compute are separate, and that's really valuable for cost savings but also for agility, right? Because now with the data share house concept, a company that builds one of these can choose to give access to sets of data to partners, right? Let's say in a supply chain, as an example that we discussed, such that a partner could very suddenly, very quickly, very easily get access to a rather large data set. Let's say it's products sold in the last 6 months or something like that, and then they could access that data and build some analysis around that for their purposes. So now you're sharing a warehouse with close partners, having just flipped a switch somewhere, right?
Yeah, that's exactly right. Yep.
Okay, so I got a couple good questions from the audience here. One, I'm pretty sure the answer is yes. I think you talked about this. You can access all kinds of data sources, right? Like MySQL or any number of other data sources, right?
Yes, that's right. So we can bring in data from as many sources as you want to. There's no limitations on that at all.
And I know you have to run here in just a minute or so. And we've got Todd Bosheen logged in as well, who can answer some questions for folks if they want to stick around. But here's a great question from an audience member. What does WhereScape say to skeptical traditional IT folks to win them over? Any magic spells you can share?
Well, yeah, I'd just say one thing. Do you want your user community, your business unit users to actually like you? If you do, then data warehouse automation and WhereScape is the way to go.
That's funny. Yeah, that's a good one. And in terms of data sources, another attendee is asking about MongoDB. Really, in terms of WhereScape, you don't care where the data comes from, right? I mean, most of it is supported natively, and you can build connectors if it's not, right?
That's right. We don't care. We can get data from anywhere. There's no limitations at all.
Yeah, that's
Great. Well, I have to go
amazing
there.
stuff.
Sorry, to call now, but thank you everyone very much for attending today and looking at WhereScape Red on Snowflake. It's been great.
Hey, thank you so much. All right, and then Todd, I think you can stick around for a couple of minutes. I mean, what we just saw there, I thought was just an amazing demonstration of what used to be an extremely slow process and now can be done in almost no time, right?
Exactly, Eric. It's amazing. He did a better demo. Jason did a better demo than I probably could have done of the value of Snowflake. And really, you know, it's really changing. It's game changing to be able to deploy what Jason deployed so quickly, and know that that's not just shadowware. That's actually code that could run and could be adapted to your own environment very easily and quickly.
Yeah, and the fact that you can store it in the cloud and make the changes to the schema, make changes to just about anything is such a huge deal because beforehand it took days, weeks, sometimes months to get a change made. To be able to have that flexibility to play around with new tables and new designs to fit new business use cases, that turns the warehouse into a very agile, responsive environment. I have to think that's just fantastic news for end users, right?
Yeah, and that's really kind of, you know, what drives people to Snowflake is to create that experience for their end users. You know, as much as we want to simplify the world of the database engineer, and, you know, I spent several years at companies like Amazon as a data engineer, and you know, as much as we want to simplify their world, Snowflake is really the goal that we have is to bring the data to the business users who are making decisions in a faster way. They can still leverage those data engineers. They're going to need them to work through all the data sets and determine the value of each data set and do some data preparation. But really, it's all about adapting to meet the needs of the end users.
Mm-hmm. No, that's good stuff. And this whole data share house concept, I think, is just fantastic because, again, you don't want to have to rebuild things if you don't need to, if you can get by not rebuilding. And this is the perfect example where you have multiple data sets, store them in the cloud, then you can provision or take away access to data sets to any number of partners, to a consulting firm maybe that's working with you, someone in your supply chain, whatever the case may be. Now you're able to extend access beyond the corporate firewall to partnerships. I cannot believe what a big change that is. So give me your thoughts on that.
Well, and it's interesting because, you know, when you think about it from an early on perspective, and I apologize if there's some background noise, but when you think about it, you know, you think, oh, well, that data is automatically available to me in my organization, but you think about the amount of time it takes to prepare that data. And how often you see companies as a result just keeping that data in a silo because, you know, as they prepare that data, the team that owns that data, you know, is able to manage it without, you know, thinking about the other data that's available in the system. And with Snowflake, simple to manage. You no longer need a team. You know, I was in the retail group at Amazon, and, you know, we had a whole team dedicated to bringing in our demographic data into the data warehouse, and they maintained it, and there were all kinds of, you know, SLAs that they had to meet and different things that they had to do. And with Snowflake, you just flip a switch and you make that data accessible, and it's still in a secure way, though. I think that's the key to all of this is that, you know, this data is very valuable to those who produce it and those who consume it, and we want to make sure that it's, you know, it's able to be consumed in a secure manner. But really, you know, the days of going out to an FTP site and downloading you know, an encrypted file and then having to get the key and decrypt it and then process the data and load it into the system are gone. And it really changes the game in terms of, again, getting that data in the hands of the business users who can use it to make business decisions.
Yeah, that's a huge point that you just made. I mean, this is a paradigm shift is what it really boils down to. Like you say, the days of downloading some FTP site, loading it in, not only is that time-consuming and painful and boring and also error-prone and expensive, but the fact is that now you don't have to do that. Now you can just provision access or take the access away. and you don't wind up with multiple copies of things. I bet every person in the business world at some point or other has encountered full-on in their face the whole issue of version control, right? Well, in the cloud, you don't have to worry about version control so much, first of all, because it's usually baked in, and you can go back in time to find the version that you want, but also because it's all in one place. You don't have 5, 7, 18 different copies of something floating all around. I mean, can we even exaggerate the value of that?
Well, we heard stories from some of our customers that they would go into executive level meetings at some of these big banks out there, and they would come in with billions of dollars in differences in the reports that they were looking at because of these systems, because one system applied a filter that another didn't, or even they may have been pulled on different dates and, you know, gone through the manipulations. And so when you can put all the data into one place and have really, you know, the promise of a single version of the truth that has been, you know, people have talked about that for years and years, but really making that possible because you don't have to then replicate the data. You don't have to copy it into a data, you know, you don't have to copy it into a data mart that, you know, can process that data. You're dealing with all the data in one place with as much compute as you need to you know, to work with that data. And then, you know, again, adding on the story of data sharing to say, okay, now I'm going to bring some external data that, you know, has value to me from a business perspective. It really does, you know, completely change. Again, it's all focused on driving that value to the business holder. So, you know, as a data engineer, I reported to a vice president who needed answers to his questions. And many times the answer that I had to give him when he asked me those questions was, you know, it'll take a couple of months to figure it out from an architecture perspective and how to build this data set out and what to do. And, you know, with Snowflake, you don't have to worry about the infrastructure. You don't have to worry about a lot of the pieces that you would have to. And then when you tie it with a technology like WhereScape, it makes it even faster and easier to focus on the data. Getting value out of data is really what we're all in business to do. And that is, you know, exactly what you can do when you bring together two solutions like WhereScape and Snowflake.
Yeah, we got a couple other specific questions from audience members out there. Does Snowflake integrate with Scoop to load data from relational database management systems?
You know, we played around a little bit with Scoop. One of the great things about Snowflake is that we've open sourced a lot of our connectors. You know, so we have a JDBC connector. We have actually a number of different connectors out available. You can go through our website to find out about them. But you know, so while I'm not aware of anyone today using Scoop, it's definitely something where, you know, you could build a connector, and you know, we would support and encourage that among both our partners and our customers.
Yep. Okay, good. Yeah, that makes complete sense. And yes, folks, I am going to go ahead and share a link to today's slides, although the demo you'll be able to check out in the archive video later on, which should be available shortly after the show, frankly. And, you know, I'm marveling to myself about how much things have changed because of this, especially this combination of technologies. You think about the power of automation with WhereScape, you combine that with the agility and, frankly, the cost structure of Snowflake, and that's such a huge deal. We talked in the radio show right before this webcast, 5 years ago even, a data warehouse would almost assuredly cost you over $1 million and would take probably 6 months to build. Now, I have to say, it's going to take you about as long as it would take you to point at the data sources and load them in there. I mean, the demo that we just watched Jason bang out was just mind-boggling in terms of its speed. So the cool thing from my perspective is I'm always thinking about end users and how their life can be made better with data. This kind of solution now, this kind of data warehouse in the cloud, can benefit not just Fortune 2000 companies, but any small to mid-sized business with just a fraction of the budget that it used to take, right?
Yeah, and that's what's so beautiful about it. This, you know, this was designed by engineers who were targeting, you know, the top of the top companies because those were the hardest requirements to meet. But the cloud really opens that up, and it allows us to deliver a solution to anyone based on, you know, how many resources you need you can get the resources you need to answer your particular business questions. And so you're not tied into a model of an appliance or something along those lines where, there's a huge barrier to entry. And, the evaluations for data warehousing platforms in the past have taken, months to years to go through and figure out, because once you make that decision, you're locked in for a certain amount of time. And with Snowflake, just the process of doing a POC or a pilot, and with the demonstration that Jason ran, if we were to run that on a customer instance, they would suddenly have that data. It wouldn't just be, smoke and mirrors and then you walk away and they can think about what they did. That data is actually resident then in the data warehouse that they can manipulate it, they can do all their testing. And so not only just to evaluate and then to deploy Snowflake is really simple, and again, there's no barrier to entry. So, if you figure out that it's going to, a POC is going to require a certain amount of resources, or the initial implementation is going to require a certain amount of resources, Snowflake allows you to work within the framework that you have financially to build that out and really, move piece by piece so that you're not putting an undue burden at the front to say, we have to make a huge commitment at the beginning.
Yeah, that again is such a massive change in terms of just the procedures that people need to go through to get something approved. Just think about how many executives need to weigh in. The CFO's office, for example, the CEO probably needs to weigh in. It's going to be a huge, huge expenditure of capital expense to get an old world data warehouse, whereas these days, operational expenses, OpEx, can get this stuff up and running. And because of the speed, the nice thing is that you can get something up and running and then be able to demonstrate the value to other people in the company, so you're not talking about a hypothetical. You're showing them what you've built, and because it's in the cloud, if they say, no, I absolutely don't want that, turn it off and walk away. You didn't lose that much money. So now the barriers to entry are so much lower. I have to think that's going to be a serious game changer. What do you think?
Yeah, exactly. It's, I was involved in organizations, large organizations that were doing, both the evaluation phase and the deployment phase. It was a multi-year project costing, just the man hours alone involved in those projects are huge. And so, being able to work with a scalable solution where you don't necessarily need to know ahead of time, how much capacity are we going to need, and do we need to spend 3 months figuring out what our capacity is going to be in the future? Well, no, we can just work with a scalable system that's going to scale out to meet our needs. So Snowflake scales in two different directions completely independently in terms of scaling your storage automatically. As you insert data into tables, it just builds out. There's no limits. You're not going to hit a threshold where, you're going to have to resize or anything like that. The storage scales out automatically. And then you can scale out through your processes. You can scale out how much compute you need to apply to that storage. And it really does change the model because, we talk to companies and they spend months doing this resource planning before they bring in a solution. And as they're working through the whole process, and any changes require, massive amounts of effort to rework the system. And with Snowflake, you can change right on the fly if you decide that something isn't working the way that you expect it to, or if you figure out that the data set you thought was going to be valuable isn't valuable, you can delete it and move on, and you're not going to be charged for that data in perpetuity because you prepaid for some kind of capacity. It's all, it's all very scalable and really looking at how the cloud was designed, what the cloud was designed for. This is really, applying it to a data warehouse. This is what makes sense to leverage those scalable resources. Why companies are shifting. We're hearing, large companies saying, we're not building any more data centers. It's too much cost. It's too little flexibility in these data centers. And they're shifting heavily to the cloud through all the different providers. And it really, Snowflake was built in that age, and it's the only, data warehouse solution built during this time frame that can understand those principles and really leverage that in a meaningful way.
Yeah, I heard a great quote a while back. Someone said, "Friends don't let friends build data centers," which I thought was pretty amusing. We have another good question here from the audience. An attendee is asking, in terms of scaling the compute, is that done dynamically, and how do you measure that? In other words, can you run some queries to see how that impacts your compute and how expensive that's going to be? Can you kind of talk about dealing with computational scalability?
That's a great question, and I think that's the number one question we get from people once they understand how Snowflake works is, how much is this really going to cost? Right. We've seen organizations that jump with both feet into AWS suddenly getting, these big, and not just AWS, all cloud providers, but they jumped into the cloud, they were excited about it, they start using resources, and then they come back and they see the bill, and they're wondering what happened. It was supposed to be cheap, and well, each little bit is inexpensive. Obviously, you can generate some significant costs, and so with Snowflake, you pay for compute on an hourly basis. So we have a concept called a virtual warehouse. It is a cluster of resources. In the case of AWS, in our deployment on AWS, it's EC2, so it's these virtual machines that are running in the cloud, and when you provision one of those, then it turns on and it's available to you, and you're going to pay for it for an hour, in hour increments. And you can decide at any point in time that you want to scale up that cluster by adding additional nodes. So we've made it simple for our users rather than having to think about, number of nodes in the cluster. We have t-shirt sizing. So we go from extra small all the way up to triple extra large, and it really kind of simplifies the process, and you see a linear growth. So as you go up from extra small to medium, each size up is a doubling of resources. And we really do see that linear relationship in the performance of the queries. But what's really great about Snowflake is that, as you mentioned, if I want to find out how much it's going to cost, I go run a couple of test queries for, a couple of dollars, and I've immediately figured out with my own data how many resources it's going to take. And so our sales team, spends a lot of time kind of working with our customers to help them build out evaluations that are going to allow them to use real-world queries with real-world data to figure out what the costs would be so that they can plan those resources effectively. And really, like I said, it's a game changer because, it's not like you're going to commit to any model and then, if something changes 6 months down the road. I've dealt with situations where a query ran in a certain amount of time at one time, but as data grows, data volumes grow, that query slows down. With Snowflake, if you identify something like that, you can just simply add additional compute resources. And again, there's a cost, but there's no need to wait for infrastructure to resize or anything like that. So it really is game-changing in the sense of how flexible you can now be and really, running real workloads to figure out how that compute can be best optimized.
That's a whole different world out there, folks. Well, my friends, we try to keep these new shows to 45 minutes. Attendee just said something funny. Building one's own data center these days is like having your own blast furnace in the backyard. Yeah, it's overkill. You don't need that stuff anymore. Folks, well, we thank you so much for your time and attention. Todd, thank you for calling in. We do archive all these webcasts for later viewing. Hop online to check that out. With that, we're going to bid you farewell. We got another one coming up in a couple of weeks. As always, hop online to InsideAnalysis.com or our media partner, Techopedia.com, for all the latest. It's a whole new world these days for data warehousing. We'll catch up to you next time, folks. Take care. Bye-bye.